Hey folks, Mr. Dell here. We are looking at trying to figure out if we have how to find the solution to a system of equations. So this is CPM's course 3, and this is 9.2.3, number 9-93. So it says Kenneth claims that 2 comma 0 is the point of intersection of the lines y equals negative 2x plus 4 and y equals x minus 2. Is he correct? How do you know? So these two equations, right, represent equations of lines. Right? So we could sit there and we could try to graph them if we wanted to figure out where these lines cross, right? So this line here would be somewhere at 4. It would hit the y-intercept as 4, and the slope is negative 2 over 1, so it would look something like that. And then this line would cross at negative 2 on the y, but then go up 1 over 1, so it would look something like this. So we could try to use a graph and figure out if that is the intersection point, right? And actually have a nice grid. But there's another way, because what's true? This equation and that line represents all the solutions, right? All the ordered pairs, the x comma y's, all the possible x's and y's that make that equation true. And this line, it represents all the x comma y's that make this equation true, right? And so there's only one pair, one xy, that would make them both true. And that's where that intersection point is. So how do we check? Is we use that point and plug it in to see. So we know x, y. So what's true? That x is 2 and y equals 0. So when x is 2, y equals 0. So let's check it out. So for this first one, y equals negative 2x plus 4. When x equals 2, so negative 2 times 2 plus 4, what does y equal? You get negative 4 plus 4. Negative 4 plus 4, sure enough, is 0. So it works for this line. So let's check this one. When y is equal to x minus 2, so when I plug in 2 into the x, 2 minus 2, what do we get? 2 minus 2 is 0. So sure enough, yes, it works for both equations. So therefore, yes, he is correct. It is the solution to that system of equations. Okay, there we go.